Estimate the value of x plus 7 over x minus 4, wherein the x value approaches 3, or the limit is 3. So this one is a kind of easy limits, wherein we can easily simply plug in the value of x in here to the equation. So again, we have x plus 7 and then x minus 4, wherein the value of x is equivalent to 3. So we have 3 plus 7 over 3 minus 4. Therefore, we have 3 plus 7 equals to 10. And then here, we have negative 1. Or simply, we have negative 10. So again, this one is easy limits, wherein you don't have this form, any number more than 0 over 0, which is basically undefined. So this one is normally not allowed in mathematics. This one is okay, 0 over 5, or any number in the denominator more than 0 is alright, because this means that we have 0 value here. Estimate the value of limits, wherein x equals to 2, and the equation is x raised to 5 plus x raised to 3 plus 5 over x raised to the 5 plus x raised to 3. So again, this one is a kind of easy limits. As mentioned, is that we can easily plug in the value of 2 to the equations without having any problem. This kind of problem, of course, is not open in differential calculus. So normally we have this form over 0, which is basically undefined or not allowed in mathematics. So here again, 5 and then x to the 5 plus x raised to 3. So plugging the value of x to the equation, we have 2 raised to 5 plus 2 raised to 3 plus 5, and then 2 raised to 5 plus 2 raised to 3. So we have 2 raised to 5 plus 2 raised to 3 plus 5 over 2 raised to 5 plus 2 raised to 3. So the answer here is 9 over 8. Again, as mentioned, this one is not open in differential calculus, but for the sake of discussion, I just included this problem. So the answer here is letter C. So compute again the limits approaches 1, wherein the equation is x squared minus 3x plus 5 over x minus 2. So again, find the value of the limit if x approaches 1. So we can easily plug it in our equation, since this one is a kind of easy limit. So x squared minus 3x plus 5 over x minus 2. Substitute the value of x. 1 squared minus 3 multiplied by 1 plus 5, and then 1 minus 2. We have 1 minus 3 plus 5. Again, 1 minus 2 is negative 1. Therefore, we have 1 minus negative 3. We have here 6 minus 3 over negative 1. Therefore, we have 3 over negative 1. Finally, we have negative 3. So the answer here is letter A. Compute the limits of x approaches 1, wherein the equation is x squared plus 2x minus 3 over x minus 1. So now this one is a kind of a difficult problem, because compared to the previous problem, we have now an answer. That is, if you check here, x minus 1, meaning to say we have 0 in the denominator, which is not again allowed in mathematics, because we are going to have undefined solution here. So therefore, there's a technique that I will introduce here. Again, we have this equation, x squared plus 2x minus 3, x minus 1. So first technique here is what we call the factoring. That's one of the technique in differential calculus, or sometimes of course we use some concept in algebra. So here, as you can see in the numerator, we can easily factor this one in a form of x minus 1, x plus 3. So if we want to double check, we have x minus 1, x plus 3, x multiplied by x is x squared. If we multiply these two, we have negative x, and then here we have plus 3x and then minus 3. That is plus 3 multiplied by negative 1. So therefore, we have x squared plus 2x minus 3, which is basically this equation. Alright, so meaning to say these two factors are okay, and in our denominator we have x minus 1. So look at this. Now we can simply cancel this one, having finally this equation. So x plus 3, and now we can substitute the value of the limit from the problem. So therefore, we have 1 plus 3. Finally, we have 4 as our answer. So the answer here is letter B. Estimate the value of the limits wherein x approaches 2 and our equation is x minus 2 over x squared minus 4. So again, this one is in the form of over 0 in the denominator wherein, again, it is not allowed in mathematics. So we have to use our technique here, which is the factoring as mentioned in the previous problem. That is x minus 2 x squared minus 4. So notice that in the denominator, we can simply factor this equation in the form of x minus 2 x plus 4, and then here again we have x minus 2, hence we can simply cancel this in. 1 over x plus 4 is the remaining in our equation. So substitute the value of the limit is 2 plus 4, and therefore we have 1 over 6, which is basically 1 over 6 is 0.1667, or let's say 0.167, so that we have letter C as our answer. Compute the value of the limits wherein x approaches 3 and our equation is x squared plus x minus 12 over x minus 3. So again, this one is a kind of a factoring problem, because if you notice, if you substitute the value of 3 in the denominator, you'll have over 0 here, which is again undefined. So let's use our technique of a factoring. So x squared plus x minus 12 over x minus 3. So again, we factor this in here. So first of all, of course, you have to consider what is the denominator. Simply write it here so that we know that we can cancel this denominator. And then, of course, think of the number or a term that if you multiply here in this first term, it will have the same result as mentioned here. So for me, it's x plus 4, because as you notice, we have negative 3 multiplied by positive 4 is negative 12. And then here, negative 3 plus 4 is basically positive 1. So again, by experience or familiarization of this factoring from algebra topics, you'll have an easy time in this kind of problem in differential calculus. So we have finally x plus 4 remaining from our equation. So therefore, we substitute the value of the limit, that is 3 plus 4, and therefore we have 7, which is letter D. Compute the limits of x approaching a, wherein the equation is x cubed minus a cubed over x minus a. Again, this one is factor limits, wherein we have to factor the numerator in this case to avoid 0 in the denominator. As you can see, if you substitute a to the x, then we have 0 in the denominator, which we always want to avoid in all cases. So x cubed over a cubed over x minus a. So from algebra, factoring this cube, we have x minus a, and then x squared plus ax plus x squared, and then finally we have x minus a. So we can again cancel this out. We have then this remaining equation, so x squared plus ax plus x squared over 1. So we substitute now the values of a squared plus a multiplied by a plus a squared. So therefore we have a squared, and then a multiplied by a is also a squared, plus finally a squared. So therefore 1 plus 1 plus 1 is 3a squared. So the answer here is letter C. Evaluate limits x approaches 4, wherein the equation is x squared minus 16 over x minus 4. So again, we are going to use the factoring here. So we have x squared minus 16 x minus 4. So the denominator, of course, cannot be factored since already in a 1-degree polynomial. But then in the numerator, we can factor this by x minus 4 x plus 4. So x minus 4 again in the denominator. Therefore, we can simply cancel this out, and we have x plus 4 in our equation. So since x approaches 4, then we can simply substitute this here. Therefore, we have 8. So the answer here is letter C. So again, evaluate the limits of x approaching 2, wherein the equation is 3x squared minus x minus 10 all over x squared minus 4. So again, we can solve this using our factoring technique. So we have 3x squared minus x minus 10 x squared minus 4. So here you can easily say that the denominator will have a value of 0, which is we want to avoid because it doesn't make sense in the solution of a mathematics. So therefore we can use again our technique of factoring in solving this equation. So this one in the numerator, we can factor this with x minus 2 and then multiplied by 3x minus plus 5. And then here in denominator, we can also factor this one as x minus 2, x plus 2. So again, this will cancel out, and what we have here is 3x plus 5x plus 2. And now we can check and evaluate. If x is equivalent to 2, then our denominator is a positive integer, which means 2 plus 2 is equivalent to 4. And then here in the numerator, if we plug in the value of x, we have 2 here plus 5. So therefore we have 6 plus 5 over 4, and therefore we have 11 over 4. That is letter A. Evaluate the limits of x approaching 3, wherein the equation is x to the 4th minus 81 all over 2x squared minus 5x minus 3. So let's first have a test. If we substitute directly the value of the limit, here we have 3 raised to 4 minus 81. Using our calculator, we have 3 raised to 4 minus 81 equal sign. So basically we have 0, which is still fine. So this form, 0 divided by any number, let's say 6, is still fine in this topic of limits. What we want to avoid is this form, 0 over 0, or any number, let's say 6 again, divided by 0, because these two are basically undefined and no meaning in mathematics. So, and here in the denominator we have 2, again 3 raised to 2 minus 5, 3 minus 3. Another test, we have 2 multiplied by 3 squared equal sign minus 5 multiplied by 3 minus 3. Now we have this form, 0 over 0, which is undefined and no meaning in mathematics. So what can we do here? So again, using our factoring technique and learn from algebra. So we have this equation, x to the 4th minus 81, and then 2x squared minus 5x minus 3. So the numerator can be factored out with our x squared minus 9, as you can see, and here we have x plus 9. Again, we have to square this one. This is again algebra principle. And then here in the denominator, we can factor this one by x minus 3, and then we have x or 2x plus 1. We can test this one as a purpose of discussion. So x minus 3, 2x plus 1. So we have again 2x squared minus 6x, and then here we have x minus 3. Resulting will be 2x squared minus 5x minus 3. That is negative 6x plus x is negative 5, which is the same as the original problem. And so again here, going back, we have this part. The equation still can be factored out with x minus 3 and then x plus 3. Still the same, and then x squared plus 9, of course, and then x minus 3, and then 2x plus 1, and then finally with this we can cancel this one. Therefore we have x plus 3, I'll use blue, x squared plus 9, and then here 2x plus 1. Again, we can check using our calculator what will be the result. So fraction 3 plus 3 multiplied by 3 squared plus 9 over 2. Let's put this in factor. 2 multiplied by 3 plus 1. So as you can see, we have positive integer on the numerator and also positive integer on the denominator. So therefore we have a good answer, 108 over 7, which is equivalent to letter C. So again, evaluate the limits of x approaching negative 2, wherein we have 1 over x plus 1 half all over x cubed plus 8. So again, our first approach is to check the equation. So 1 over negative 2 plus 1 half, 1 over 2. So it means that the numerator is 0, which is still fine. And then we try to check the denominators, that is negative 2 cubed 3 plus 8. So we have 0 here. Again, this equation is undefined, and we have to avoid this solution in mathematics because it has, again, no meaning. So what we can do here is use our technique of factoring. In this particular problem, I will introduce to you another way to solve this. So first, let's do some factoring here. So 1 over x plus 1 over 2 x cubed plus 8. First, let's try to simplify the equation, this part. So common denominator is 2x, and then 2x divided by x equals 2 plus 2x divided by 2 is x. So x cubed plus 8 again. Therefore, we have 2 plus x, numerator 2x, x cubed plus 8. So still, we have the same scenario. scenario, we have the numerator equivalent to 0 and denominator equivalent to 0. But look at this equation. From algebra, we can factor this out. So 2 plus x, 2x, and this one can be factored out using the equation or the relationship of x plus 2, and then we have x squared minus 2x plus 4. So again, from algebra, if we have a cubed plus b cubed, we can factor this one as a plus b, and then a squared minus ab plus b squared, which is in this case, which is I applied in this particular case. But again, this one is the basis of this factor. So again, going back in here, we have 2 plus x, then x squared minus 2x plus 4. So we observe that we can cancel this one, 2 plus x, 2 plus x, and so we have now 1 over 2x, x squared minus 2x plus 4, and then we can now substitute our limit, that is negative 2. So we have 1 divided by 2 multiplied by negative 2 multiplied by negative 2 squared minus 2 multiplied by negative 2 plus 4, and then we have to close, minus 1 over 48. So the answer here is letter D. Evaluate the limits of x approaching 4 with the equation 3 minus the square root of x plus 5 all over x minus 4. So again, our technique, or inside your mind, if you try to change or put the limits into this equation, that is, for example, in the denominator, it's obvious that we're going to have 0 in the denominator, which is again undefined. So we can now introduce the one technique in here to solve this kind of equation, that is called rationalize. Earlier, we use the technique of factoring from algebra. So now let's try to use this rationalization in this problem. So 3 minus, again, x plus 5, and then x minus 4. So what do I mean when I say rationalization? Normally in algebra, if we multiply this by 1, doesn't change the equation. So but the technique in here when we say rationalize is that we try to multiply the same equation with the equivalent to 1, because if I multiply this equation, normally we should multiply in opposite form. If you have 3 here or negative here, we should multiply this by positive, that is again x plus 5. So here in the numerator, to retain the value of 1, I should have the same, so 3 plus the square root of x plus 5. So remember that we have from algebra, if we have a minus b multiplied by a plus b, we have a squared minus b squared. So in this particular case, if we multiply the numerator, you see the negative sign here and then positive sign. So this means that this one is my a, and then I have here b. This means that 3 multiplied by 3, that is a squared, 9, and then minus the square root of x plus 5 multiplied by positive x plus 5 is basically x plus 5, because here radical sign will cancel out. So we have x plus 5 in here. And then also in the denominator, as you can see, we have still x minus 4. So the technique here is not to multiply these two, but instead to wait until we simplify the numerator. So still we have x minus 4 multiplied by 3 plus square root of x plus 5. We simplify this. So 9 plus, sorry, this must be negative, 9 minus x minus 5. So this means that we have here a simplified of x. So we have 4 minus x, and then here x minus 4, and then 3 plus the square root of x plus 5. So still we have positive 4 here, minus 1, and then x minus 4. So what I will do is just multiply this by negative. Negative in the numerator and negative in the denominator, which means that I have negative 4 now, and then plus x, same here, x minus 4, and then this negative I will apply to this equation. So that is negative 3 plus square root of, this must be negative also, minus square root of x plus 5. This means that we can simply cancel this out because they are the same, and then finally we have 1, and then negative 3 minus the square root of x plus 5. So we substitute now the limits, which is equivalent to 4. Again, fraction 1 over negative 3 minus square root of 4 plus 5, and then close, equal sign, negative 1 over 6. Again, take note that in algebra, we can write this as negative 1 over 6, or 1 over negative 6, or simply 1 negative here over 6. So the answer here is letter A. So compute the limits of x approaching to 1 with the equation square root of x plus 8 minus 3 all over x minus 1. So again, it's obvious that we're going to have 0 in the denominator, which is normally we avoid. Alright, so what we can do now is again use the rationalization technique. So that is, again, if we have this equation, x plus 8 minus 3 form x minus 1. So we just simply multiply this with the opposite of this. Similar equation, x plus 8. This time I will use plus. And then also here, x plus 8 plus 3. Meaning to say, this part is equivalent to 1. So we retain the meaning of the problem. And this case, basically, again, if we remember, if we have this equation, xa squared minus b squared, we expand this, then we're going to have a plus b and then a minus b. So the same here. We have negative and positive. So meaning to say, if we multiply these two, we're going to have x plus 8 again. Now, I will put squared here to avoid confusion, and negative 3 multiplied by positive 3 is basically 9. That is the same here. And then we keep same denominator, so x minus 1 and then square root of x plus 8 plus 3. So here square root will cancel out, meaning to say we have x plus 8 minus 9. So x minus 1 again multiplied by x plus 8 plus 3. So if we see this in the numerator, we can simplify this as x minus 1. That is 8 minus 9 equals to negative 1. So x minus 1 still in the denominator, x plus 8 plus 3. So we see that we can cancel this one, and therefore we have 1 over square root of x plus 8 plus 3. We simplify, we plug in the limit, which is equivalent to 1. So that is 1 over 1 plus 8 plus 3. Here we have 3. Square root of 9 is 3 plus 3. Therefore 1 over 6. The answer here is letter A. Evaluate the equation x minus 27 over x raised to 1/3 minus 3, where the x value is approaching 27. So previously we already introduced the technique of factoring and rationalizing to solve this kind of equation, but now I will try to give another approach. So that is x minus 27 again, x raised to 1/3 minus 3. Different approach means I can write this equation as x 1/3 raised to 3. So same, this will cancel out, meaning to say x still has exponent equivalent to 1, and then here 3 cubed. So the same, 3 multiplied by 3 multiplied by 3 is 27, and I have here 1/3 minus 3. So I will not do any factoring and rationalizing. Take note, from algebra we have this relationship. If we have a cubed minus b cubed, this is the same as we have a minus b, and then a squared plus ab plus b squared. So I will do it here. So a x 1 over 3 minus 3, I will keep the exponent as 1, and then here we have x 1/3, this is our a, then we have to square this one, plus we have x raised to 1/3, and then we have here 3, so multiplied by 3, and then plus, of course, b squared is 3 squared. In the denominator we have this equation, x 1/3 minus 3. Obviously we can cancel this part, this one and this one, so therefore we have this equation, x 1/3 raised to 2 is basically 2/3, plus we have here 3x 1/3 plus 9 over 1. So it's quite obvious that we have a very simplified equation. So if we substitute the value of x, that is 27, so 27 raised to 2 over 3 plus 3, 27 1/3 plus 9 equals sign. We have 27 raised to 2 divided by 3 equals sign, plus 3, and then multiplied by 27 raised to 1 divided by 3 equals sign, plus 9 equal to 27. So the answer here is letter D. Evaluate the equation negative 7 over y plus 10 squared, wherein the limit is approaching negative 10. Let's have a recap. Take note that in limits for calculus, we have a form easy, wherein if we have this kind of problem and then we plug in the value of the limit, let's say 2 over x plus 1, and then since x is equivalent to 1, we don't have any problem directly substituting the values to the equation. So this must be, by the way, equivalent to 1. And then we have this form wherein we have 0 at the numerator and 0 in the denominator, which is we normally avoid in mathematics because it is undefined, doesn't make sense for mathematical problems. So this form can be solved by different ways. Okay, we introduce some ways and technique in how to solve this kind of problem. It's either factoring or rationalization. And number 3 form of a problem for limits is that we have here a not 0, okay, over 0, which has a 3 possibility of answer. First is that we have a negative, infinity, and undefined. So this kind of problem is this form. We have the case number 3. So how to solve this? So I will introduce to you some small technique, traditional way of calculating this kind of problem. So again, y approaches -10, and then -7 y plus 10 squared. Alright, so another reminder, let's say reminder. From algebra, we learned that if we have a number here, alright, and if we divide it by a very small number, let's say 0.0001, we're going to have 100,000 here, alright, which means huge or big amount, huge. So if we divide a certain number to a very small number, we have a huge number, or it's infinite. Also, if we have 1 divided by 0.0001, the same value, alright, we have 100,000, but in this case, since we have negative here, then therefore we have 100,000 and equivalent to negative infinity, alright. And if we divide these two, we have undefined value. So this is the third case which we are going to use in this kind of problem. So how to solve this? So first of all, we have to graph it. Since we know that y equals to -10, alright, there are some numbers, okay, let's take this as our 0. There are some numbers that will approach -10 on this direction from top, and there are some numbers here that will approach -10 from the bottom. And what are these numbers? So this can be -9.9999, right, or -9.999, or 9.99, etc. And here from the bottom, what are the values that will approach -10 on this direction towards upward? So we can have here -10.001, or -10.01, alright, or 10.01, etc. So we can try it here. We can try test this units according to this scenario. That is, again, the limit is -7 over y plus 10 squared. And if my y is approaching 10 from the top side, so let's take this as top side, and here from the bottom side. So positive plus sign means approaching the limit from the top. So this means that if I substitute this value, any value in here, let's say 9.9999, alright, what will happen? So 9.999 plus 10. So still we have -7 here. We keep it not 0. And then here, as you can see, we can check what will be the value. Using our calculator, we have -9.9999 plus 10. So it's still positive. And if I square it, don't forget we have to square equal sign. So that's, by the way, even smaller than 9.999. This means that we have a very small number here, okay, which means we have infinite. While if the limit -7 y plus 10 squared, if the limit is approaching from the bottom, so we take negative sign, okay, -10 here. We have values approaching 10 from the bottom. So let's take this. So what will happen? -7 and then -10.001 plus 10 squared. What will happen in here? So this one is negative, alright, plus 10 squared is basically positive, alright. The denominator still have a value of a positive, and I kept the numerator the same. So this means we have infinite, also here. Notice that they have the same sign, positive and positive, infinity. And if the solution are equal, that's the answer, right? Sorry, I have to correct this one. So take note here, we don't have positive infinity. We have to consider this one, negative 7, all right, over the positive infinity is basically negative infinity, all right, negative infinity. Also here, we have negative 7 on the numerator, and therefore we should have negative infinity as our answer. And therefore, the answer here is negative infinity. So, the answer must be letter C. Evaluate the equation of x to the fourth plus 5x minus 3 all over 2 minus the square root of x squared plus 4, wherein the limit is x approaching 0. So again, we have this third case. Case number 3, wherein if we substitute this here, right, this x equivalent to 0, we have 2 minus 0 squared plus 4, and therefore we have 0 in the denominator. Square root of 4 is 2, so 2 minus 2 is equivalent to 0. And then here we have a positive number, okay, not 0. Okay, so case number 3 as discussed previously. So there's a technique that we can use to solve this kind of problem. So we take, okay, there are 3 chances of answer. So we have positive infinite, negative infinity, or undefined. So let's take it. All right, so x to the fourth plus 5x minus 3, and then 2 square root of x squared plus 4. All right, so now if we draw the illustration, let's say this is 0, okay, this is x. All right, so there are some numbers approaching 0 from this direction. So this one is negative, approaching the 0 from the left. And then there are some numbers here approaching 0 from the right, okay, right and left. So what are these numbers? So 0 meaning to say we have negative 0.00001, and here we have positive 0.00001. All right, so let's test this. Okay, so let's take that 0 is approaching the limit from the left side, that is negative. All right, so limit 0 negative, wherein the equation is still x to the fourth plus 5x minus 3, and then 2 square root of x squared plus 4. Okay, so we take this one, we substitute the values. So negative, okay, let's use this 0.0001, okay, 0.0001 to the fourth plus 5 multiplied by 0.0001 minus 3, and then 2 minus 0.0001 squared plus 4 equal sign. So using our calculator, we can easily solve this. Okay, so 0.0001 raised to the fourth, and then plus 5 multiplied by 0.0001 minus 3 over 2 minus the square root of 0.0001 squared plus 4 equal sign. So we have a huge number. Okay, so we can take this as positive infinity. All right, next, if limit is approaching from the right side, so again the same equation. So x to the fourth plus 5x minus 3, 2 minus the square root of x squared plus 4. So now we substitute this value. Positive, let's say positive 0.001. Okay, same as this, but positive. So let's take this as x equals to 0.001. Substitute the values. Oops, I made a mistake here. I use positive, so let's take this as positive, and now let's do the negative. So small correction. So let's take this as negative now from the left. Okay, 0.0001 negative squared plus 5 multiplied by negative 0.0001 minus 3, and then 2 minus the square root of 0.0001, again negative, that's my mistake earlier, squared plus 4. So what is the answer? Again, if we found that the two limits have the same value, positive, this means that's the answer. Alright, so negative 0.0001 squared plus 5 multiplied by negative 0.0001 minus 3, and then 2 minus the square root of negative 0.0001 squared plus 4 equal sign. So same huge amount of number. So we have positive infinity here. So the answer here, since they are equal, that is limits approaching to the left and limits approaching to the right, both of them are giving us a positive infinity, then therefore the answer must be letter B. Evaluate the limits of x minus 1 all over x squared multiplied by x plus 2, wherein the limits is x approaching 0, and here take note we have a strange exponent which is positive. What does it mean in differential calculus in the limit subject? So take note that this one is a little bit strange or different from common problems. So this means that if we have this graph, let's take this as 0. So let's take this as 0. Therefore, we have 1 here and negative 1 here. So there are some number here. For example, 0.001, 0.001, okay, 0.01. So they are approaching 0 on this direction from the right. So normally we take this as positive. And there are some numbers approaching 0 from this side, which is from the left. And normally in differential calculus, we take this as negative. So what is the value of this function when x approaches 0 on this direction from the right? Again, here it is important to apply the principle. There's no shortcut in here. So we have again x squared x plus 2. So if we take this as positive, what does it mean? So this means we can assume this value and then plug the values, this number, to the equation, that is 0.0001, or we can use 0.0001 or 4 O's, minus 1, and then here we have 0.001 squared multiplied by 0.0001 plus 2. Alright, what is the answer? We can use the calculator. Numerator is 0.001 minus 1 over 0.001 squared, right, multiplied by 0.001 plus 2 equal sign. So we have negative infinity. That is because in the numerator, as you can see, we have negative, and then here we have positive. So negative over positive is negative infinity. And so the answer here is letter C. Evaluate the limits of 5x squared plus 7x minus 8 all over minus 4x squared minus 2x plus 1, wherein the limit x approaches infinity. So let's try to solve this. 5x squared plus 7x minus 8, and then negative 4x squared minus 2x plus 1. So again, the limit is x approaching infinity. Take note that one of the technique in here is that we divide the numerator and denominator by the highest power of x if the equation involves a polynomial. So this means that we have 5x squared. Since the highest exponent is 2, then we divide it by x squared. First, write all the equations. 7x, again, x squared minus 8 over x squared over 4x squared over x squared minus 2x over x squared, and then plus 1 over x squared. So what we do have here, this will cancel out. 1x will cancel, so we have x, and then here we have 8 over x squared. Also here we can cancel, and then here 1x will cancel out, so x, and then we retain this one. So we have this resulting equation, 5 plus 7 over x here minus 8 over x squared, and then minus 4 minus 2 over x plus 1 over x squared. Infinity means huge amount of number. Let's say 1 million, 10 million, 100 million, etc. And just imagine in this particular case, if you divide 7 over 100 million, then it's almost 0, almost approaching 0. Similar to here, 8 divided by the square of 100 million, this will become almost 0. And therefore, all these values with x will become 0, almost negligible. So therefore, we have here 5 over negative 4, which is our answer. That is letter A. Evaluate the limits of x squared minus 3x plus 1 all over x cubed plus 2x squared minus 5x plus 3. So again, our technique here is that to divide the equation to the highest level of exponent. So this means that since we have x squared minus 3x plus 1, we have x cubed plus 2x squared minus 5x plus 3. One of the techniques is again to divide polynomial in the terms to the highest exponent of x. This means that we have x squared over x cubed minus 3x over x cubed plus 1 over x cubed. And then here we have x cubed over x cubed plus 2x squared over x cubed minus 5x over x cubed plus 3 over x cubed. So we can cancel this out. We have 1 over x here, and then also here we have x squared, and then here this will cancel, x here, and then x squared, and then we have to keep this one. So this means that our equation now becomes 1 over x in the numerator minus 3x squared plus 1 over x cubed, and then finally we have 1 plus 2 over x minus 5 over x squared plus 3 over x cubed. So now again, since we have here infinity, that is a huge amount of number, this part, as you can see, this numerator will have a huge amount of number. Let's say 999,999. 1 over this amount is almost negligible, almost 0. Same as here. This part will become 0. Also 0, also 0. All the terms with x in the denominator will become 0. And what we do have here, we have 0 over 1, which is basically equivalent to 0. Our answer here is letter A. And one of the alternative way to solve this is by using Galiasanya's technique, wherein we can substitute if we have infinity limit, then we can assume this one is 9999. This means from the original equation, we say that we have 999,999 squared minus 3 multiplied by 99999. I'll just replace this with that to avoid confusion. Multiplied. So multiplied by plus 1, and then we have here 99999 cubed plus 2 multiplied by 99999 squared minus 5 multiplied by 99999 plus 3. And then we use, of course, our calculator to calculate it. We have, first of all, fraction 9999 squared minus 3 multiplied by 9999, and then plus 1, and then 9999 cubed plus 2 multiplied by 9999 squared minus 5 multiplied by 9999 plus 3. Cosine. So we have this very small number, negative 7. This means that we have 0.00001239799 number, which is basically almost equivalent to 0. So again, this matches our answer with that additional way of calculation. So again, the answer here is letter A. Evaluate the equation x cubed plus 2x squared minus 5x plus 3 all over x squared minus 3x plus 1, wherein the limit is x approaching infinity. So again, we have here the equation x cubed plus 2x squared minus 5x plus 3x squared minus 3x plus 1. So one of the technique again here is, if we have the limits approaching infinity, what we do for this kind of polynomial is that we divide. We identify first the highest level of exponent in the denominator. In this case, we have x squared, and we divide all these terms with that particular highest exponent. So this means that we have x cubed over this one. I will use different color later on. So 2x squared minus 5x plus 3. Same as in the denominator, we have x squared minus 3x plus 1. So now, what is this? X squared over x squared over x squared over x squared. So we retain the meaning of the equation. So these are basically equivalent. Now, what we can do is to, of course, cancel this. So this means we have x in here. We have to cancel this one. So this means we have factor 1. And then here we have x and then 3 over x cubed. So this will cancel out. 1 minus this will cancel out also. We have x in here and then we retain this. So basically we have x plus 2 minus 5 over x plus 3 over x squared. And then here we have 1 minus 3 over x plus 1 over x squared. Now we evaluate. Take note, this means we have infinity plus 2. And then here we have 5 over infinity is basically 0. Also here we have 0. Also here in the denominator, if we found the variable x in here, this means this becomes 0. Also here 0, 0, also here 0, and then 0. So what we do have is infinity plus 2 over 1. And this one is a huge number. Plus 2, of course, it will retain infinity. This means that by observation, if you see this kind of equation, and if the numerator exponent, the highest exponent in the numerator is greater than the exponent of the denominator, then most likely the answer is infinite. That is positive infinite. So the answer here is letter B.